Good afternoon. Welcome to another discussion for tips for young meteorologists. Today I want to touch on something very important, and that is teleconnections. As in, when you read a teleconnection chart, what does that mean in terms of real weather impacts and some of the features that you should be looking at besides just one individual chart. So let's take a look at some of. So this is a chart that you typically see. You might also see a chart that are free. From the National Weather Service showing the GFS. It's basically the same idea where you have your teleconnection, in this case Arctic oscillation, dropping towards a negative state. You can also see the North Atlantic oscillation, the European Pacific oscillation. So you could see just a wide variety of data. Okay, it's pretty straightforward. This is coming from weathermodels.com, which is a paid website, but you could also pull it up at the National Weather Service. Let's see, let me pull it up real fast. Here it is. You could also go to the Climate Prediction Center, say that 3 times fast, and you could look up the NAO and the Arctic Oscillation. Let's see here. So you could look at the forecast. Here's the Ensemble's Outlook. Okay, very similar, same idea. Okay, and you could look it takes the data all the way back to December of 2020. You can see how it evolved. So again, understanding these charts is really important, really good to use, right? But what does it always mean? Does this always mean that even in the spring that you're going to end up with stormy conditions? Not exactly. First, before we go any further with model data, I want you to remember something very important, and that is the conservation of air mass and conservation of energy and the equation of state, which is right here. Now, look, I'm not expecting you to go and do these equations and pull them out and work on them. I'm not trying to scare you. But I want you to know that it's important that you understand what these equations mean when it comes to forecasting, especially this right here, conservation of air mass and the law of thermodynamics. See, by understanding these two, you know what is possible and what isn't in a model forecast. So if you see, let's say, a solution of 2 below normal heights right next to each other, you know that is likely not going to happen because there should be a balance in the atmosphere between those 2 lower heights. So that takes us to 500 millibars. Let me pull that up here. And again, this is a forecast from the European Ensemble Guidance, and you can see how you get your negative NAO pattern. There's our textbook ridge, and there's a nice little upper level low. Understand that when you're looking at this data, you have to understand a variety of factors. What's going on in the rest of the atmosphere? What's going on in the Pacific? Is there a progressive pattern slamming into this block? And what time of year is it? Also, where is the block positioned? You see, yes, you could have a negative NAO, but is it an east-based, which is out here, or west-based, which is somewhat here? And also, is it displaced north or is it displaced south? So in this case, when you're looking at this block, you also have to look at the other factors involved. A nice ridge down here towards the upper Midwest. Confluent flow here over the northern mid-Atlantic, right? Air is coming in, and then you see your best divergence and diffluence is out here, right? On the eastern side of our upper level low. So some might make the assumption that based on this data and this data that the eastern United States is in for a very stormy end to March. But if you look at the 500 millibar pattern here, which you can see right here, the reverse is actually true. That because of the way that this block is aligned, that this would suggest that your best potential for stormy weather is out here towards the western and central Atlantic, and your best chance for sinking air is down here towards the northern mid-Atlantic, right around here, And your best chance for below normal temperatures and unsettled conditions would be right around this upper level low. So basically Maine and maybe the Green and White Mountains up around Vermont and New Hampshire here. And your block isn't going to last very long. Why? Because your Pacific pattern, which you can see very nicely here with your Eastern Pacific Oscillation, is basically very volatile. See, when you see this doesn't tell you exactly what's going to happen, but it tells you what's not going to happen, which is that a block is going to remain in place. Because when you see this type of signature, that means that you're going to have storms on the move. Okay, you have troughs and ridges marching their way through, and they're marching their way through right into that block. And so they'll chip away at that block and gradually weaken it and gradually start to have it collapse. So when you're looking at a map and you're looking at a chart for a oscillation, whether it's the Arctic Oscillation, North Atlantic Oscillation, always remember those equations so that way you have a better understanding of what's happening in the atmosphere, understand what is possible and what isn't, and then take a look at the 500 millibar map and say, okay, where exactly is this block located? Because the statistics only tell you so much, and then you apply that to your forecast. Hope that provides a helpful tip for you as you continue to learn how to forecast. And as always, have a great day and stay safe out there.